All right, so it says consider the function g of x, which is 3 times sine pi of x, not pi of x, sine of pi x. All right, so the function g is horizontally stretched by a factor of 2, then translated down to obtain f. Which graph matches the described transformation? So first we got to think about what this looks like. So the amplitude goes from 1 to 3. So this is going to go from the amplitude from 3 to negative 3. Well, let me write some stuff down so it'll make a little more sense. So g of x, my amplitude is 3. So that's going to stretch it vertically from the original sine function. Okay? And then pi, remember that the period is for sine is 2 pi over b. But in this particular case, b is equal to pi, right? This is b, this is a, because it looks like this, right? Sine of x. So we got a sine of b x minus c plus d.
Pardon the interruption. At this time, varsity baseball to the gym. Varsity baseball to the gym. Thank you.
And so c equals 0 and d equals 0. All right. So getting back to this, the period then would be 2 pi over b, which is pi. The pi's will cancel, so the period is 2. So just a rough sketch of what this graph would look like. It would go from 3 to negative 3, right? And the whole period would be 2. So it kind of looked like this. And it would do the same thing on the other direction. And this would be like negative 2, and this would be negative 1. I think, let me double check. So this is the cool thing. Once you learn how to transform functions and you memorize the parent functions, you literally don't need a calculator. But I know this might be because you guys are just learning this. You might not be able to just imagine a graph in your head. But that's the power of knowing these transformations. You could take a parent function and change it in your mind, like just do it in your mind. All right, so I'm gonna do the trig, z trig. Now I think I set it up to where the thing is pi. So let me change this real quick. My tick marks. Yeah. So my tick marks. So I changed my tick marks to half pi because we've been doing a lot of trig stuff. So if I change this to 1, that means that on my x scale, it's just going to count by ones. I was counting by pi's. So now when you cross, you can see it crosses right on the integer values. And it's basically, like I said, it goes from positive 3 to negative 3. And one whole period, it's 2 units in the x direction. So let's take a screenshot. This is what that's what this looks like. So now we need to transform that by a factor of 2. So we want to horizontally stretch it out by a factor of 2. Now what that means is this number here, the period goes from 2 to 4. So we got to think about what B is, and then we're going to translate it down to units. So what does that mean? Well, what we're going to do, I know that A stays the same, which is 3. We got to figure out what B is. There's no horizontal shifting, so C still stays 0. But now to go down to units, B has to equal -2. Okay. So I want this to equal 4. So I think B has to be pi over 2. I think. And the reason I say that, because if the period on G is 2 pi over B, and I say 2 pi over 2, remember that when you divide a fraction by a fraction, that's the same as multiplying by the reciprocal. So the reciprocal of pi over 2 is 2 over pi. And the pi's would cancel, and I get 2 over 2 equals 4. So my new function, g of x, would still be 3 sine of pi over 2 x minus 2. And so now let's graph that and see what we get. That's kind of hard to see, so let me change this real quick. So I'm going to make our parent function that we started off with to a dotted line. And then I'm going to make our new function a solid line. Whoops. Let's see what that looks like. So there's the original function that we started off with, and this is the new function. And let's take a screenshot of that. And so if you're curious as to what that actually would look like when you go to do the actual problem, you'll be given 4 choices, and it'll look like this.
Teachers, excuse the interruption. All varsity track athletes, please report to the gym. Thank you.
So that's what it will look like when you're all done.